Hey, fifth period chemistry, it's Miss Butler. This week you're doing more stoichiometry. So last week you learned about mole to mole ratios. This week you're going to calculate moles using those ratios. So to review from last week, a mole to mole ratio is a ratio of the moles of two substances in an equation. So here I've got iron plus sulfur yields iron 3 sulfide. Stoichiometry is like a recipe for chemistry. It's going to tell you how much you have or how much you're going to get after a reaction. P.S. This is a synthesis reaction because two smaller compounds combine to join one big one. So this is what you did last week. You had a balanced equation. Make sure your equation's always balanced. And then you can write mole to mole ratios. It's like a recipe. So if you had to compare moles of iron to moles of sulfur, you look at these front coefficients. The front numbers tell you how many moles are in the reaction. So you can say this is a 2 to 3 ratio, 2 moles of iron for every 3 moles of sulfur. You can also write it the other way and put the 3 on top, 3 moles sulfur for every 2 moles of iron. If you compare iron to iron 3 sulfide, it's the same thing. Look at your front coefficients. 2 moles of iron are needed to give you 1. Remember, when there's not a number, that just means a 1 coefficient. 1 mole of iron 3 sulfide. So here's what's new this week. In a chemical reaction of iron and sulfur, how many moles of sulfur are needed to react with 1.42 moles of iron? So you always start with a balanced equation. This one's already balanced for you. I would write down what you have to start with. It says that you are reacting 1.42 moles of iron, so I write that on the left. And then they're asking for how many moles of sulfur, so you put that on the right of your math problem. I put question mark moles of sulfur. That's where I'm trying to go. So here's where I'm starting, and here's where I'm going to finish. So here's where you use your mole to mole ratio in the balanced equation. If I'm comparing moles of iron to moles of sulfur, that's a 3 to 2 ratio using the front coefficients. 3 moles of sulfur in this reaction for 2 moles of iron. So I write 3 on top and 2 on the bottom because I'm about to use dimensional analysis. You get points this week for showing your work, and you also get points for showing what units cancel. Since I started with moles of iron, I have to put moles of iron on the bottom of my dimensional analysis work because moles over moles will cancel out. I'm left with these units, moles of sulfur, and that's what I want, moles of sulfur. So I'm ready to use my calculator. So how we did these before is you multiply the numbers on the top, 1.42 times 3, and then divide by 2 because 2's on the bottom. So 1.42 times 3 gives you 4.26. Divide that by 2, and your answer is 2.13 moles of sulfur. So if you start this reaction with 1.42 moles of iron, you get 2.13 moles of sulfur. This is called stoichiometry. Here's one more. If you take propane gas and you mix it or react it with oxygen gas, this is a combustion reaction. A lot of energy will be released and you get some carbon dioxide gas and some water vapor or water and gas state. This equation is already balanced, so anytime you do stoichiometry, make sure your equation is balanced. Look at the question. How many moles of carbon dioxide can be produced when you start with 2.25 moles of propane gas? So just like before, your equation's balanced. I would write on the left of my work what I have to start with. I'm starting with 2.25 moles of propane gas. And on the right side of the math problem, you should write down where you're going. We're trying to calculate how many moles of carbon dioxide. So then I look and I get the mole to mole ratio. There's 3 moles of CO2 in this reaction for every 1. There's no number there, so there's a 1 there. 1 mole of propane gas. So I put 3 moles of CO2 over 1 mole of propane because I want to cancel these units. Don't forget, you get points for showing your work and you get points for canceling the right units. So the moles of propane gas cancel out and I'm at moles of carbon dioxide, which is what I want. So now I use the calculator. 2.25 gets multiplied by 3. You don't have to divide by 1 because it's just a 1 denominator. And so I get 6.75 moles of CO2 as my answer. So if I start with 2.25 moles of propane, I get 6.75 moles of CO2 in this reaction. This is called stoichiometry.